Hey guys, so we're looking at section 3.2 today. This is where we're going to introduce law of cosines. So the two cases that we needed to talk about from our oblique triangles, which law of sines could not solve, are going to be where you are given all three sides of the triangle, or you are given two sides and the included angle in between them. So when you're given these three sides of your triangle, basically, which means you would need to find the three angles. If you are given two sides and the included angle, then of course we need to find the missing angles and the side. Law of sines would not be helpful in solving those. So this is where we introduce our law of cosines. So you have the standard form and you have the alternative form. So depending on if you are finding the side of the triangle, you would use the standard form. If you are trying to find the angle, you will use the alternative form. So just depending on what you're trying to find, we'll use one or the other formula here. Now again, you can look at the proof for law of cosines in your textbook if you like. But let's go ahead and take a look at our example over here. So we have three of the sides given to us, and they're basically asking us to find the three angles. Okay, so you can see our measurements for the sides are 8 feet, 14 feet, and 19 feet. So as you can see here, it's always a good idea to start by finding the angle opposite from the longest side. So our longest side would be side B, which means angle B is going to be our largest angle. So we want to start by finding angle B here. Now, since we are finding angle B, we will need to use the alternative form of our law of cosines, and it's going to be the second equation here. Cosine of B equals a square plus c square minus b square over 2ac. Okay, and basically one thing you should note over here is that these are the same exact formulas, the same exact equations. The only thing is we have taken the standard form and solved it for cosine of A, cosine of B, and cosine of C to get the alternative form. Okay, so we'll be using the second formula here. Cosine of B equals a square plus c square minus b square divided by 2ac. We go ahead and plug in our numbers, simplify that, and you are getting cosine of B is going to be negative 0.4509. So when you have a negative cosine value, that of course means you are looking at quadrant 2, right? Because if you think about it, in our unit circle or just in our coordinate plane, cosine values are positive in quadrant 1 and cosine values are negative in quadrant 2. So that automatically, just by having this negative, we know that our angle B is going to be an obtuse angle. And of course, when you take the arc cosine on this negative value of 0.4509, you will get angle B to be approximately 116.80 degrees. Now, once you find angle B, to find your angle A and angle C, you can actually use your law of sines over here. And then using law of sines, we can come up with our angle A. So you can see using this, we're getting sine of A to be positive 0.3758. So again, use your arc sine function to find that. Now they're telling us since angle B is obtuse, of course, because that's coming out to be 116.80 degrees, and a triangle can have at most only one obtuse triangle, then that automatically tells us that A has to be an acute angle. And so since A has to be an acute angle, you don't need to find two different answers for angle A, because sine function can of course be positive in quadrant 1 and quadrant 2, but since we know that A has to be an acute angle, you just need to find A, which will come out to be 22.07 degrees, and then using our angle A and angle B, you can subtract that from 180 to get angle C, and angle C will come out to be 41.13 degrees. So again, you are using the law of cosines to find the largest angle, which will be across from the longest side. So once you find that by using law of cosines, then to find the other two angles, you can use the law of sine. So we're finding angle A here. We're using law of sine. We come up with the value of sine of A. Now, since we know that angle B is an obtuse angle, that tells us angle A has to be acute. So again, you just need to find the acute measurement for angle A and then subtract from 180 degrees your angles A and B to get angle C. So now let's repeat that process for our example over here. So example 1 is again asking us to find the three angles for a triangle where those three lengths or sides are given to us. So let's go ahead and take a look at this example over here. Okay, so the longest side that we are going to have is going to be side C, right? Because that is 12 centimeters, which means the largest angle is going to be angle C in our case. So again, we are going to be using law of cosines to help us find the angle C, okay? So let's write down the formula for law of cosines, and since we're finding angle C, that's going to be the alternative form of cosine of C, which will come out to be A squared plus B squared minus C squared divided by 2 times AB. So of course our A value is 6, that will be 6 squared. B is 8, so that's 8 squared minus 12 squared divided by 2 times A, which is 6, and B, which is 8. So you can plug this in your calculator and see what you come up with. So of course we get 36 plus 64 minus 144 divided by 96. And you don't have to take it step by step. If you don't want to, you can just plug this into your calculator and you will end up getting, and this is not going to be an exact answer, negative 0.458, and then that 3 keeps repeating. So we basically have cosine of C, which is approximately equal to a negative number, right? Negative 0.45833, where your 3 is repeating. So if you take cosine inverse on this number, or arc cosine, doesn't matter, you will end up with, and you can do it on the decimal approximation, just make sure you're keeping all the decimals, or you can also do cosine inverse on this fraction, which was negative 44 over 96. It doesn't matter, but rounding it to 2 decimal places, you should come up with an angle measurement of 117 degrees and 117.28 degrees. And of course you can see this is going to be an obtuse angle. So if this angle C is an obtuse angle, then our other remaining angles have to be acute. Okay, so this guy is 117.28 degrees. So after you find angle C over here, you can actually use the law of sines to find the other angle. So let's take a look at our next angle. So using law of sines over here, let's go ahead and find angle A. So for angle A, I am going to use the formula sine of A over A equals, since we just found angle C, we can now use sine of C over side C. And again, to get sine of A by itself, we'll go ahead and multiply both sides by A. So let's see, sine of A is going to be sine of angle C, which is 117.28 degrees. Side C was going to be 12 centimeters, and side A was 6 centimeters. So again, you can plug this in your calculator and we will get approximately 0.444388,639. So again, you can see this is a positive value. So that means the angle potentially can be in quadrant 1 or quadrant 2. But like I said, since we know angle C is obtuse angle, angle A has to be an acute angle. So when you find angle A, you are going to be doing sine inverse or arc sine on this decimal approximation we came up with. And this will come out to be, again rounded to 2 decimal places, approximately 26.38 degrees. Okay, so remember this has to be an acute angle, so 26.38. And now we just have to find this remaining angle B. So of course that's going to be pretty straightforward since we have both angles A and C. For angle B, you just take your 180 degrees, subtract angle A and angle C from it, and you should come up with B is going to be 36.34 degrees. So you can actually see this is going to be a combination of using both law of cosines and law of sines to come up with this answer. So that's 36.34, and we have our three remaining angles. Okay, alrighty, so that was example 1. So just as a fact over here, we are saying, do you see why it was wise to find the largest angle first? So they are saying, knowing that the cosine of an angle, you can actually determine whether your angle is going to be acute or obtuse. So again, if your cosine value comes out to be positive, then that means you are looking at quadrant 1. So your angle is going to be between 0 and 90 degrees. However, if your cosine value comes out to be negative, that means your theta value, your angle, is going to be between 90 and 180 degrees. So that would be quadrant 2. Okay? So that kind of helps you out. If you know the largest angle is going to be acute, then basically, if the largest angle is acute, then your remaining 2 angles will also be acute. At the same time, if your largest angle is obtuse, then your remaining 2 angles will be acute because you can only have one obtuse angle in your triangle. So that's why you always want to go ahead and find your largest angle first. Okay? Alrighty, let's take a look now. What if you are given 2 sides and their included angle? How would we go about solving that? So you can see in this triangle over here, we are given C as 12 meters, B is 9 meters, and angle A is 25 degrees. So since we have sides B and C, we want to go ahead and find side A. So to find side A, we are using the standard form of our law of cosines here. So A square equals B square plus C square minus 2BC multiplied by cosine of A. So go ahead and enter those values for sides B and C and angle A. Solve that. So here you are getting A square equals, or approximately equals, 29.2375. So we'll go ahead and take a square root on both sides. Now remember, normally with square roots, we get one positive and one negative root. But since we are talking about the measurement of a side of a triangle, we know our measurement cannot be negative. So that's why your answer will come out to be a positive 5.4072 meters. So we have found our third side. Now we still have those 2 angles that we need to find. Okay, but before we get into that, they are saying when you are solving an oblique triangle where the 3 sides are given, you use the alternative form of your law of cosines. When you are solving an oblique triangle, when you are given 2 sides and the included angle, you actually use the standard form of your law of cosine. So they're just basically talking about in which situation, which form of the law of cosines you end up using. All right, so now let's go ahead and find our two missing angles. So now that we have found all three sides, we can actually use the law of sines to help us find our missing angle over here. So for angle B, we are using sine of B over B equals sine of A over A. Get your sine of B by itself and plugging in the values for side B's and A, for sides B and A, and then angle A, your sine value is coming out to be approximately 0.7034. So since this is a positive sine value, and of course this is less than 1, you know your angle B can fall between quadrant 1 and quadrant 2. So in this case, once you do the inverse, the inverse sine function or the arc cosine function, you will actually come up with two values for angle B. So you will have a value that falls in quadrant 1 and a value that falls in quadrant 2, which means to get our answer then, based on B1, we will have to calculate angle C1, which comes out to be an obtuse angle. If you use the value for B2, which is an obtuse angle, you will get the value for C2, which will be an acute angle. Okay, let's go back to our triangle over here. Just a second. Okay, so if you look at the triangle, you will see our side C is 12 meters, side B is 9 meters, and when we calculated side A, it was 5.4072 meters. So you will see side C is our longest side, which means angle C has to be our largest angle. So since angle C has to be the largest angle, that means you are actually going to be using the calculations from B1 and C1, because this is where angle C is larger. With the second calculation, C is a very small angle, which means we actually don't use this calculation. We are going to use this one, and that automatically means for angle B, you are going to be using 44.70. So angle C will then come out to be 110.30 degrees. Angle B comes out to be 44.70 degrees, and you can kind of see we're talking about that here. Side C is the longest side, so angle C has to be the largest angle. Okay, so let's take a look at our example over here. We are given A is 80 degrees, side B is 16 meters, side C is 12 meters, and they're asking us to find the remaining angles and sides. So let's take a look at this guy over here. Okay, so let's start by finding our third side, the A side. So again, for finding side A, we are going to need to use law of cosines, but we are going to use the standard form. So that's going to be A square equals B square plus C square minus 2BC, and then we multiply this by cosine of A. So for us, B will be 16 squared, C will be 12 squared minus 2 times 16 times 12 times cosine of A, which is 80 degrees. So again, you can put this in your calculator, or you can break down your calculation. So 16 squared gives us 256, 12 squared is 144, 2 times 16 times 12 will give us 384, and then cosine of 80 degrees is going to be 0.173648178. Okay, so if we go ahead and calculate this further, that should be a decimal there. And again, you really don't have to break this down, but basically your A square, and this will be an approximate value. We've actually been doing approximate values starting from here. So when we take 400 minus the 66.6809, you are going to get 333.3190998. And again, since we are only interested in positive answers, since this is the measurement of a side of a triangle, we're not going to worry about our negative square roots. So basically what would happen is you would end up taking a square root over here. You normally get a positive and a negative root, but like I said, discard your negative answer. And this should come out to be square root of 333.3190998 is going to be approximately 18 point. And again, I'm just rounding it to 4 decimal places like they did in your notes. And of course here our measurements are given to us in meters, but let's round it down to 2 decimal places for the final answer. And this will come out to be side A of 18.26 meters. Okay. So if you will look at our triangle over here, we've got side A as 18.26 meters, side B as 16 meters, and side C is 12 meters. So side A is the longest side, which means angle A is going to be our largest angle. And if our largest angle is 80 degrees, then that means both angles B and C have to have values which have to be smaller than 80 degrees. Okay, so now let's go ahead and see how we can find our other 2 angles. So for that, you can actually use law of sines now. So let's say we want to find angle B next. So let's use this version of our law of sines. To get sine of B by itself, let's go ahead and multiply both sides by side B. So we will get sine of B equals sine of A, and A is 80 degrees. We just calculated side A as 18.26. Actually, you know what? To avoid any decimal approximations, let's go ahead and use our 18.2570 for side A, and then side B was of course given to us as 16 meters. So when you go ahead and do this calculation, you should end up getting sine of B as 0.8630626061. And of course we'll need to find the sine inverse for this. So B is going to equal sine inverse of this decimal number. So 0.8630626061. Now technically, since your sine of B function is a positive number less than 1, that actually means that we can have 2 different answers that you can get from the sine inverse. So for B1, when you go ahead and do this calculation, that will come out to be approximately 59.66 degrees. And then for B2, we can just do 180 degrees minus 59.66 degrees, and that comes out to be 120.34 degrees, right? And then based on each one of these values, we can calculate our C angles. So for C1, we will do 180 minus 80 degrees for angle A, minus 59.66 degrees for angle B, which will of course come out to be 40.34 degrees for C1. And then for C2, we will do 180 degrees minus 80 degrees minus 120.34 degrees, and you will see here C2 actually comes out to be a negative because we've already subtracting 180 from 180, and we are left over with negative 20.34 degrees. So of course that right there should tell you we cannot have a negative angle. And additionally, remember what I said, since side A was the largest side, angle A has to be the largest angle, which means our angles B and C cannot be larger than 80 degrees. So that right here should have told you that this value we cannot use because this is larger than 80 degrees, it's bigger than angle A, and it's not going to work. So you can see again, C2 is not going to work for us either because that's a negative angle, which means we will be using 59.66 degrees for angle B and 40.34 degrees for angle C. So this guy is 59.66 degrees and this guy is 40.34 degrees. Okay, so there you go. That's how you would go about solving example 2. Alrighty, so now let's go ahead and take a look at our application problem over here. Okay, so we are given the pitcher's mound on a women's softball field is 43 feet from home plate, so you can see that 43 feet right here, and the distance between the bases is 60 feet, so these are the 60 feet measurement here. And they're telling us the pitcher's mound is not halfway between the home plate and the second base. So they want us to know how far is the pitcher's mound from first base, so that's this distance of H that we are trying to find. So let's go ahead and take a look at how we can solve this. So they're saying in triangle HPF, so that's going to be triangle HPF over here, angle H is going to be 45 degrees, and basically you can see we have a square over here, right, between our bases and the home plate, and you can basically see that since these are 90 degree angles, when this line HP or line segment HP bisects that angle, you're basically dividing that 90 degree angle into two halves of 45 and 45. So that's where we got that 45 degree angle for angle H. Your length of distance F is 43 feet and the length of distance P is 60 feet. So basically we are given two sides and the angle included, right? And we are trying to find this third side, which is distance H. So we're basically using the formula for the standard form of law of cosines, where you have H squared equals F squared plus P squared minus 2PF multiplied by cosine of H. And you know, the easiest way to remember these formulas is if you are trying to find side H, then you will have angle H over here, and then these two are going to be the other two sides. So F and P, F and P. So that's kind of how these law of cosine formulas are set up. So again, go ahead, plug your numbers in. You get H squared as 1800.3290, and then take a square root on that number, and you're getting the distance H to be approximately 42.43 feet. Okay, so kind of like how we calculated our side A in angle 2, that's the same thing we are doing in this application over here. Okay, all right guys, let's take a look at our example over here. So they're saying in a softball game, a batter hits a ball to dead center field at a distance of 240 feet from the home plate. The center fielder then throws the ball to third base and gets a runner out. The distance between the bases is 60 feet. They want to know how far is the center fielder from third base. So I have actually created a little diagram over here to help us out. Okay, so let's take a look over here. So remember, again, they're telling us the batter hits a ball to the dead center field. So that's this letter C over here. That is a distance of 240 feet. So from the home plate to center field, you're looking at that long distance of 240 feet. They are saying the center fielder then throws the ball to third base, that's your T, and gets the runner out. The distance between all the bases are 60 feet, and they want to know how far is the center fielder from third base. So you see that triangle in red? That's basically what we are trying to solve over here. So again, you should see that we are given the side which is part of our base here, going from third base to home plate. So that's your side, which is given to us as 60 feet. Again, since these corners here would make a 90-degree angle, this line HC is bisecting that angle. So angle H is going to be 45 degrees again. So we have that given angle. And then that distance from home plate to center field is given to us as 240 feet. So that's our side again. So you're given two sides and the included angle over here, which we're trying to solve. So again, we will need to start by using law of cosines over here. And let's look at the given information. So we are given side C is 60 feet. We are given angle H is 45 degrees, and we are given distance T is 240 feet. So to find the distance between the center field and the third base, that's our length H, you are going to have H squared is equal to C squared plus T squared minus 2 times CT multiplied by cosine of H. So C squared will be 60 squared, T squared is 240 squared, minus 2 times 60 times 240 times cosine of angle H, which is 45 degrees. Okay, so if you did 60 squared, we would get 3600. 240 squared would come out to be 57,600. Just multiplying 2 times 60 times 240, that will give us 28,800. Cosine of 45, now you could do decimal approximations or you can use your unit circle. So cosine of 45 will actually come out to be square root of 2 over 2. Okay, so let's go ahead and add those first two numbers. 3600 plus 57,600 will come out to be 61,200. I can actually take this 2 in the denominator and reduce our number on the top, which will come out to be 14,400. So you can actually write this as 14,400 multiplied by square root of 2. And just cleaning this up, when you multiply these 14,400 with square root of 2, you are going to get 20,364.6753. Okay, and go ahead and subtract those two numbers and you get 40,835.3247. Okay, and again, to get H by itself, we will need to take a square root on both sides. Whenever you take a square root, you get one positive, one negative root. Just like you did before, discard your negative answer because our side of a triangle cannot be a negative number. And taking that square root, you should get approximately 202.077 rounding it to a whole number, you should get a total of 202 feet. So that's how far the center fielder is from third base. So that's approximately 202 feet. Okay, so you can see how we can use this law of cosines to help us come up with this answer. Okay, alrighty, so this was our example 3 over here. Now our next example here is again talking in terms of our bearings over here. So they're telling us, and you've got this image to kind of follow along, a ship travels 60 miles due north. So basically you started out at point A and we went 60 miles due north. Then the ship will adjust its course and basically it's going in the northwest direction, and you can see it goes 80 miles in that direction. At this point, your ship is going to be 139 miles from where it departed, which was point A. So you are now at 139 miles from the point of departure, and they want to know what is going to be the bearing from point B to point C. So basically they're asking us to find this angle over here. Okay? Alright, so let's go ahead and take a look at what we are given. So basically we are given all three sides of our triangle. Okay? So since we need to find the bearing from point B to point C, and remember again, your bearing is always going to be with respect to the vertical line going from north and south. So using our alternative form of the law of cosines, we use this formula here for finding cosine of B. Plug in our values for the sides A, B, and C, and you get cosine of B is negative 0.9709. So since this is a negative number, that tells us our angle B is going to be a quadrant 2 angle. Okay, so that means we are looking at, again, do your cosine inverse on this number and you should get angle B as approximately 166.14 degrees. And now obviously angle B, and let me see if I can show you that here, is going to be this angle here inside the triangle. So when we are trying to find our bearing angle, which is going to be this one from the vertical, you are actually going to have to do 180 degrees minus this 166.14, and you are going to get 13.86 as the bearing angle. And of course, from the north-south direction, when you changed course from point B to point C, you started going in the northwest direction. So you would have north 13.86 degrees west. This is how, remember, we write our bearing angles. So that's going to be your bearing from point B to point C. Okay? Alrighty, so we've got a similar example to that over here. So we've got a ship travels due east. So you're starting at point A and we're going due east and it changes direction. So after traveling 30 miles in this, you're going 40 miles due east, and then when you change direction, you are traveling 30 miles in this new direction, and then from your point of departure, that will put that ship at 56 miles. So same kind of example here, they're asking us to find the bearing from point B to point C. So when we're talking about bearing, again, we need to draw our little vertical line. So we're talking about this little angle here from the vertical to angle C, to point C. So let's go ahead and take a look at this example over here. Okay. So in this case, let me go ahead and do my little line for our bearing. So this will be our north-south line, and then this is the angle we are asked to find. Okay? So let's go ahead and take a look at what we can do. So of course you can see we are given all three sides of our triangle. So side A is 30 miles, side B is 56 miles, and side C is of course going to be 40 miles. So we need to actually find that large angle B over here first. So we need to find this angle here and see what we've got. Okay, so let's start with law of cosines again. And since we are looking for angle B, we will be using the alternative form of our cosine law of cosines. For cosine of angle B will be equal to a square plus c square minus b square divided by 2ac. A squared will be 30 squared, c squared would be 40 squared, minus b squared, which would be minus 56 squared, divided by 2 times 30 times 40. Okay, so if we do these square calculations, 30 square would be 900, 40 square will be 1600, 56 squared will be 3136, divided by 2 times 30 times 40 will come out to be 2400. So just bringing this all together, let's see what we come up with. So this will simplify into negative 636 divided by 2400, and that actually comes out to be negative 0.265. So again, since this is a negative value, that tells us our angle B is going to be in quadrant 2 again. So angle B is going to be between 90 and 180 degrees. So let's see what that comes out to be. So angle B will be cosine inverse of negative 0.265, and that guy will come out to be approximately 105.37 degrees. So this is angle B for our triangle AB and C. So it's this bigger angle here, which is 105.37 degrees. So if you just think about it, how do you think we can find that angle for the bearing from point B to point C? So if you think about this, from this little dotted line that I drew for our bearing, if you look at this, and I'm going to try and do this in a black pen, so you're going to have this angle here actually just by itself forms a 90-degree angle, right? Because that's going to be your corner. So if you take the angle we just found, 105.37 degrees, and subtract 90 from it, you will get this angle that we are looking for, which I have marked in red. So to find our bearing, you are going to get 105.37 degrees minus 90 degrees, which will of course end up giving us 15.37 degrees. So your bearing, and remember you are going in the direction of, again, remember this is north, so you are going in the direction of northeast. So your bearing is going to be north 15.37 degrees and then going east. So this is the answer we are looking for our bearing. Okay, so I hope this kind of helps you see how we came up with our bearing measurement over here, and you can compare both example 4 over here and the problem number 4 that we looked at. Okay, so the next thing we actually want to talk about is how we can use law of cosines to help us find the area of a triangle. So they're saying we're actually looking into Heron's area formula over here. So this is of course named after a Greek mathematician by the name of Heron. So just a little historical note here. We're saying Heron of Alexandria was a Greek geometer and inventor. His works describe how to find areas of triangles, quadrilaterals, regular polygons that can have sides, a three-sided polygon to a 12-sided one, and also for circles, surface areas, and volumes of three-dimensional objects. So a lot of different formulas that are credited to him. Okay, so this is our Heron's area formula. When you are given the sides of your triangle, all three sides A, B, and C, your formula is going to be area equals square root of the quantity S multiplied by S minus A times S minus B times S minus C, and S is defined as taking those three sides A, B, and C and taking its basically dividing it by 2. So A plus B plus C divided by 2. And again, you can look at your textbook for the formula on Heron's area here. Okay, so let's take a look at this example. They're asking us to find the area of the triangle using Heron's area formula. You're given the three sides of your triangle. So the first thing we will actually need to calculate is this value of S, since that's going to be a big part of our calculation here. And taking all three sides, 43 plus 53 plus 72, you get 168. Divide that by 2, you get S equals 84. So then you are multiplying under the square root. 84 times 84 minus 43, 84 minus 53, 84 minus 72. Multiply all of them together, take the square root, and your area comes out to be 1131.89 square meters. Again, since this is area formula, you always have to write your measurements as square units. Okay, so we just have a simple example here for us. Using Heron's area formula, find the area of the triangle with sides A equals 5 inches, B equals 9 inches, C equals 8 inches. So let's go ahead and take a look at this guy over here. So for our area formula, the first thing we need to do is calculate S. So that's going to be A plus B plus C divided by 2. So in our case, that would be 5 plus 9 plus 8, which of course comes out to be, what will that be? 22 over 2, which of course will give you 11. So you get the S value as 11, and then using our Heron's area formula, we have square root of S multiplied with S minus A, S minus B, and S minus C. Okay, so this will be 11, and then 11 minus 5, 11 minus 9, 11 minus 8. So that's 11. 11 minus 5 will of course give us 6. 11 minus 9 will give us 2. 11 minus 8 will give us 3. So if we go ahead and multiply everything inside the radical, 11 times 6 times 2 times 3, that will come out to be 396. And then of course you take a square root on that. So we will get approximately, and again I'm going to round this to 2 decimal places, 19.90, and this will be square inches. Okay, so you can write it square inches, or you can write it as an abbreviation like this. Okay, so this is going to be our area for this triangle. So not too bad. It's a pretty straightforward example, as you can see. And then we are actually comparing the different area formulas that we have for triangles. So of course you've got your standard formula, which is area equals 1/2 times base times height. And then in the last section, when we were talking about law of sines, we saw the area formula for the oblique triangle, which can be area equals 1/2 BC sine of A, or 1/2 AB sine of C, or 1/2 AC sine of B. And now, using our law of sines, we came up with Heron's area formula, where your area equals square root of the quantity S times S minus A times S minus B times S minus C. So now you have three different area formulas depending on what information you are given and when to use these formulas. Okay? Alright guys, so this is what we had to talk about in section 3.2. So this is the only section we have left to talk about in chapter 3. So we are done with chapter 3 now. So we'll go over some examples in class and answer any questions that you guys might have. So be careful, stay safe guys, and I will see you in class next time. Take care. Bye-bye.